With this day and night globe, what it's showing you is when...
It's okay, you can do it.
You're making me nervous.
I'm sorry. I'm sorry.
With this globe, you're going to see the difference between day and night. And what's also really cool about this globe is if you come to the side, you can see the shadow tilting. And then as the Earth spins, the shadow moves, and it's representing the Earth tilting on its axis. And what's cool about that is it tells you what season it is. For example, right now, it's in summer and it's rotating to an equinox, and that makes it either autumn or spring. And then it'll just keep rotating, and the seasons will change, and the days will change as the globe spins.
Cool. Is that one? Yeah. And then the next one.
Next one.
So this is called turbulent orb. Turbulent orb is basically, it simulates a planet's rotation and also the atmosphere. The outside is the atmosphere. It always stays still, never really moves with it, but when you spin it, you start to get the simulation of a planet's rotation. Now with the planet's rotation, it also simulates any kind of gases that are on the inside, mixed with any kind of superstorms. The slower it is, say when this slows down, it's going to look just like Earth. Not really a lot of superstorms, but there are storms. You see the rotation as well. The faster you spin it, it's going to start looking like Saturn or Jupiter. Nice and fast. And you're able to stop this. This is always staying still, planet's atmosphere. A little bit faster, then go the other way. See now it's the rotation mixed with also the superstorms on the planet as well. So the superstorms, the gases, and the rotation all kind of mix in. And it's kind of in this little fishbowl of an atmosphere, which always stays still, always protecting us from any kind of debris from space, but also protecting space from anything going on the planet as well.
Awesome, thanks. And then? Is that it? Is it the, okay.
Yeah, that was it.
Okay, when I do it, I start it with the top. Okay. So, and then tell them, you guys, like this.
Is that
It's not funny. I really don't know how I did drama in high school. I can't. Okay, what's holding the globe up on the top is the metal, and what's holding it down is what keeps us down, gravity. So when the two forces work together, with this globe, they levitate it, and that's what keeps it in the middle.
Basically, the Earth is one big giant magnet, just like every other planet, including the sun, which is also basically a star. It's one big giant magnet. Those magnetic forces are always kind of pulling with each other. So say this is like the sun, one big magnet. Without our magnetic energy, we're going right to it. Bottom, say it's just bottomless space where Pluto is, out yonder, whatnot. Without that magnetic energy, we're going to fall right into space. But that magnetic energy, we're nice and right in rotation around the sun, and also just staying afloat, just like that. And then obviously we're rotating all the time as well. But basically we're one big giant magnet. Without that magnetic energy coming from our core, which is the center of the planet, there's no way for us to stay afloat. We would fall into gravity of the sun, or go right in space, just fall out. And that's pretty much it. Now I'm going to show you to the jumping ring. The jumping ring basically is when I press this red button right here, which it can only be pressed and worked when it's green light. A lot of electric energy is going to go through these coils right here, it's copper coils. When it does, it's going to go into this rod. Now, the electricity turns into heat in this rod, and it goes out into this ring, to the inside of this ring, and it shoots it right up. Now, without it, the heat's just going to disperse. Nothing. But when I have this ring on it, which is pretty much aluminum, it's nice and light, and I wait for this button to turn green, press it up, and it'll shoot up, okay? But that's only because the electricity turns into heat in this rod. And then the heat picks this up, shoots it up. That's it.
I actually think it's magnetism.
It's the heat.
It's heat? Okay. I know that. Is that it? And you just do the 4?